Hello everyone, welcome to Chemazon-Complete Chemistry. So in this video we are going to learn about the basics of total synthesis and the terms related to that, like target molecule, what is FGI, retrosynthesis, disconnection, synthon and synthetic equivalent. Okay, we'll also learn with the help of some of the examples. Okay, so imagine this image as a jigsaw puzzle that we used to play in the childhood. So how do you play a jigsaw puzzle? So the image is initially in the form of all the pieces joined together, and what we do, we separate them or disassemble them first, and then we again join to get back the original image. Similarly, what is total synthesis? For total synthesis, we first do something called as retrosynthesis. Okay, and what is retrosynthesis that we are seeing now? Retro means backward. So whatever molecule we want to synthesize or prepare, we first do the back analysis or retro analysis. That is why it is called retrosynthetic analysis. Okay, so tm means target molecule. Okay, that is the molecule that you want to prepare. So just like we break the puzzle pieces, similarly we do is something called as a disconnection. Okay, disconnection means breaking a bond. Okay, breaking a bond, that is called as a disconnection. And what is the meaning of logical disconnection, we'll see in the next video. So you have to break a bond and transfer the electrons to either one of the fragment, okay, such that what you get is, so this is called as a retro arrow, okay, or retrosynthetic arrow, like two vertical lines and then normal like this. So this is called as a retro arrow. This we use when we are writing a retrosynthetic analysis for any compound. Okay, and what you get is the separated, just like we got the separated puzzle pieces, similarly we get the imaginary fragment. Okay, this does not exist in real life, but they are imaginary fragment, that is called as synthons. Okay, these imaginary fragments are called as synthons, and by looking at the synthons, now you can see the arrow, electrons are transferred to, so how you have to transfer electron to a more electronegative atom like oxygen. Okay, suppose you transfer to a less electron to a less electronegative atom, that would be a bad disconnection. Okay, we will discuss that in the next video, what is a good disconnection and a bad disconnection. Okay, so O being more electronegative gets minus charge, and R plus, that is, it is less electronegative, so it gets positive charge. So they are imaginary fragment called as synthons, and these can be prepared, or we can get this, we have to think that we can get this fragment from the commercially available starting material. Okay, that is equivalent to starting material, or it is also called as reagent, or it is also called as reactants, or another word is synthetic equivalents. Okay, synthetic equivalents or starting materials. Okay, so this is a retrosynthetic analysis, and after this, so this is a basic simple idea. First you go for the retrosynthesis, that is you plan the synthesis, you take the final molecule, you break that at logic, you do a logical disconnection, then you think of what starting material is required, or that is called a synthetic equivalence, and then you do the forward synthesis. Okay, that then you do the forward synthesis for making the target molecule, that is starting material, use some suitable reagents. Okay, and you do something called as FGI, that we'll see in the next slide, that is called functional group interconversion. Okay, and by using some reagent you will get the target molecule or TM. Now let us understand this with the help of an example. Okay, now suppose we have a carboxylic acid molecule as a target molecule. So first what you will do a disconnection. So here you can see they've done a disconnection, and the electrons are transferred to R minus. Okay, R minus, that will be the nucleophile or electron rich species, and since this R got minus charge, the carbon will get the positive charge. Now can you think of a molecule where carbon has a positive charge? Yes, it can be carbon dioxide, because here you can see there are two oxygen also present. So this also we'll understand in detail in the next video. This is just a basic introduction. Okay, what are the synthon and the corresponding synthetic equivalent for different fragments, that we'll see in the next videos. Okay, so nucleophile R minus, from where we can get R minus? Either Grignard reagent, or another option is alkyl lithium or RLI, from there also you can get. So that will be the nucleophile and the electrophile. Okay, so this is the retrosynthesis. Now we do the forward synthesis. Okay, Grignard reagent, R minus will attack the carbonyl carbon, you will get O minus, and second step you do protonation or addition of H plus ion to get the carboxylic acid, that is the target molecule. Okay, so what is functional group interconversion? So it is basically you convert one functional group to another, that is, for example, secondary alcohol gets oxidized to ketone, or reverse, that is reduction of ketone to alcohol, that is oxidation reduction. This is one example of functional group interconversion. Another is addition elimination. Alkene, you add water by means of Markovnikov and anti-Markovnikov addition by different ways. Okay, that is addition, or you add acid into an alcohol, that will undergo elimination. Or another example is substitution or hydrolysis. Okay, substitution of this acyl halide will give ester. Hydrolysis of ester, we can get the starting material. Okay, so these are some of the examples of the FGI. This also we will study in much more detail in the next video. Okay, now why we are studying this in much detail? So there are some naturally occurring molecules that they are called as natural products. Okay, and they have biological activity. Okay, they have biological activity, or they are basically the drugs or medicine that we take or consume when we suffer from in disease. So synthesis or preparation of these molecules becomes extremely important, okay, without which it is very difficult. Okay, the entire medical industry cannot run without this total synthesis. Okay, so total synthesis is basically synthesis of the natural product or naturally occurring molecules by using simple or cheaper starting materials, and by using lesser number of steps or minimum number of steps possible. So we'll see this one example and we'll end this video. So this is the target molecule. First you do FGI. This acid can be synthesized from ester by hydrolysis, right? And here in alkene can be synthesized from the ketone by Wittig reaction. So this is functional group interconversion to get intermediate A. Now here we can do this logical disconnection. We have studied Friedel-Crafts acylation. So this we can take the acyl chloride or acyl halide and this as the aromatic molecule. So from B and C you can get A. Okay, so this was a retrosynthesis. Now coming on to the forward synthesis. So it starts from this molecule dialkyl halide in presence of AlCl3, that is Lewis acid, and toluene. What we will get? Friedel-Crafts as alkylation reaction, you will get B. Okay, and in B you add C, that is this acyl halide. So Friedel-Crafts alkylation followed by Friedel-Crafts acylation. Okay, you will get compound A. Now this is A here you can see it is a ketone. Okay, and what is the next step? This is called as a Wittig reaction. So ketone, by doing CH3, that is one carbon Wittig, you will get this alkene. Okay, ketone gets converted to alkene. This is the Wittig reaction. This is called as a phosphorus ylide intermediate. Okay, NaNH2 is the base, sodium amide is the base. So you get D, and the last step, now we got the last step is what? It is you have to do the hydrolysis. Okay, so if you compare this final target molecule and this intermediate D, you can see there is only one difference, ester, and in final molecule there is acid. So last step would be you do the hydrolysis. Okay, hydrolysis of ester to acid. Okay, you will get the final target molecule that is named as bexarotene. Okay, so last, what is total synthesis? Just like you prepare a cake, for preparing a cake, you need the ingredients, you think of the ingredients or the starting material. Similarly, for synthesis of naturally occurring molecule or natural product, you think of, you do a retrosynthesis or logical disconnection, and you think of the commercially available. Okay, the starting material must be cheaper so that in industry it can be synthesized on a larger scale. Okay, if the starting material is expensive, then it would be very difficult. Okay, so for a larger scale or in kilogram scale, if you want to synthesize a very important biologically active drug, then you must have cheaper starting materials. Okay, so that is what is called as total synthesis. Synthesis of the drug molecule or naturally occurring molecule, biologically active molecule, using simpler starting material. Okay, so that's it for this video. In the coming videos, we'll understand each step in much more detail. Thank you.